Red Nike shoes under 100 is not just text. spaCy's EntityRuler extracts brand and price into filters, while keeping the remaining words available for ranking. You'll use spaCy EntityRuler to extract brand, category, and price, convert them into structured filters, and preserve residual terms for ranking. I'm Professor Pi, teaching search and IR with simple Python. People don't type neat, structured queries. They mix constraints, brand, price with descriptive bits like color or fit. If you treat the whole query as plain text, your search can return items that match red or shoes, but ignore the brand or the price the user asked for. Extraction turns parts of the query into structured filters your index can enforce, and leaves the leftover words to decide ranking. spaCy fits here. It's compact, fast, and lets you write rule patterns so processing stays light. EntityRuler watches for phrases like a brand name or a price cue and tags them as entities. With one pass, you get typed spans like brand, category, and price. That split is useful. Enforce price as a numeric cap. Send brand to a catalog filter, and still use words like red and shoes for relevance. The downside is manual pattern coverage, but for product catalogs, common synonyms repeat and it's manageable. We'll build a tiny parser that produces three things: a small set of structured filters, a list of tokens kept for ranking, and a simple mapping step to normalize category words into catalog values. Keeping it compact makes the idea concrete before you scale patterns. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. To start, let us show the smallest pipeline that actually recognizes a brand. This snippet makes the pipeline extract a brand entity from the query, so the brand no longer lives as just another token. The code uses spaCy.blake.en, adds the EntityRuler with nlp.addPipe, and registers a brand pattern via ruler.addPatterns. When you call NLP query, spaCy writes the match into docents instead of leaving it untyped. The visible output shows the extracted brand entity, the first simple step toward filter-aware retrieval. Great! A single brand is detected. Real queries, though, usually contain more than a brand. We still need category and price to be typed, so the index can enforce them. This example shows the pipeline recognize category and price, so queries carry enforceable constraints, not just text. It adds another ruler.addPatterns entry for a category phrase, and patterns for price cues that match a word like under or below, followed by a numeric token. The price rules cover tokens such as under and below, without changing the rest of the pipeline. The visible output shows three typed entities, meaning the query now carries structured intent. You can use to apply numeric taps or category filters before ranking. Now that entities land in docents, we need to shape them into filters and keep the leftover tokens for scoring. This code converts spaCy docents into a retrieval-friendly shape, so constraints become filters and don't leak into ranking. The loop builds filters from each entity, parses the last price token as max price, and records token positions in blocked. Any tokens not in blocked become terms for ranking. The visible output shows three filters were created, while red remains available for relevance scoring, which cleanly separates hard constraints from soft signals. This also shows a design choice. Treat price as a hard numeric filter, and leftover words as soft relevance cues. Patterns often match user words that don't match your catalog vocabulary. Next, we'll keep the raw text, but attach a canonical catalog value. This snippet demonstrates using EntityRuler pattern IDs to normalize query values so the index sees catalog vocabulary. The ruler.addPatterns entry still matches the raw text sneakers, but its ID stores the canonical value shoes after NLP runs. Category EntID holds the normalized value, while the span.text keeps what the user typed. The visible output shows both forms, which matters because retrieval filters usually need the catalog term, while you may want the raw phrase for logging or debugging. Finally, let's connect extraction to a minimal retrieval baseline, so the whole filter plus rank flow is clear. This example ties the EntityRuler output into a tiny retrieval baseline, so you can see constraints enforced first, then ranking applied. The query is parsed once with NLP. Entity values go into vals, and tokens without an entity type become terms for ranking. A small item list stands in for a product index. Brand, category, and price filters are applied first. Then the remaining text read is used to pick among the candidates. Item B matches brand and category but fails the price cap. And item C matches color but fails the brand, so neither should win. The visible output shows the kept result and the leftover ranking term, completing the filter plus rank flow and giving a clear mental model for how parsed constraints prevent false positives, while ranking still discriminates similar items. If you map this to a real system, swap the toy list for your product catalog and apply the same filters against indexed fields. The same parser can run at query time in a low latency service and send structured constraints to your search engine, while leaving a concise ranking query for scoring. What this is: a small, rule-driven parser that turns query phrases into structured filters and leftover ranking terms. Use it when your product search has stable catalog fields and a manageable set of synonyms. A few hundred patterns often covers common queries. One caveat: pattern coverage and synonym mapping are manual work and need ongoing attention as user language shifts. A concrete next step: add a catalog normalization table for category and brand synonyms, and measure how many queries map to an index category instead of none. Tune mappings to raise filter recall and watch precision at top results change. If practical IR that teaches code helps you, subscribe and watch the IR videos.